It probably won't surprise you to learn that structures are just used like any other variable when it comes to passing them in and out of functions. Let's have a look at that. Just like any other variable, if you wanted to create yourself a function called print emp, which would be short for print employee, you could pass it an employee, just like that, emp1, and it would hopefully print it out. What would the definition of print emp actually look like? Let's have a look. Print emp might look like this. Obviously it has to take an employee as a parameter. So inside the round brackets you put struct employee. Remember, that's the name of the type now, struct employee, and then, well, any old variable name for it, emp, that'll do. And then inside that function it just works as you would expect. Emp.age is how you refer to, say, the age element. So if you were thinking about it, that's probably what you would expect it to work like, and that's exactly what it does work like. Similarly, functions can return structures. In other words, you could have a function called reademp, which could have as its return value a structure. So if it had it as its return value a structure, you could then assign that structure that it returns into another variable. That's called a structure copy. So you create a variable called emp1, and then you can assign the value that is returned by the reademp function into emp1. What would reademp look like? Well, it would probably look something like this. There is reademp on the end of the line with brackets after it. Notice it doesn't take any parameters, but it does have a return type. What's the return type? Well, the return type, instead of being int or float, it's struct employee. That's the return type. So obviously that's going to have its own little local variable called emp, which I haven't actually shown in the slide, but you can assume that it'll be there, struct employee emp inside the reademp function. We can read into it using scanf or whatever we like, and then we can return it using return emp. So a structure can be a return type. Okay, let's now go and see if we can do something very similar to that in our code fragment that we were looking at just a moment ago. Here is struct2.c in the chapter 11 folder, which is essentially struct1.c or struct.c, sorry, just modified a little bit. I've created those two functions that I told you about just a moment ago. Here is our reademp function, which, notice it has a return type of struct employee. The very first thing that it does is it creates a little local variable called struct employee. So this is a structure. It has a name, address, and age, and a salary all embedded within it. Then we ask them for the age. We won't bother asking for the rest. I'm sure you can extrapolate and figure out how those are going to look. And then when that's done, we return the entire employee, age and all, even the name, address, and salary that haven't actually been read in yet. That won't matter if we don't actually try and use them. And then printEmp is actually a lot easier. We pass it in a parameter, which is a struct employee. We call that emp. And then we just print out emp.age. Well, that line of code there has just been cut and pasted out of the main that we had just a moment ago. Now, main is going to be really straightforward. We will read the details, or we'll just read the age, of course, into our employee, pass that back from reademp, and store it in emp1. Then we will copy the entire structure of emp1, this is a structure copy, and put it into emp2. Then we will print out emp2, passing emp2 as a parameter to printEmp. So theoretically, whatever age we entered into emp1 will be copied into emp2, and thus we'll be able to print it out. So let's try that. Compile and run. Please enter the age, 36, age is 36. Now, obviously that's a very simple output, but it's proving that a few things are happening here. Quite a lot of things are happening, actually. It's proving that we can, first of all, return an entire employee structure from a function, which is what's happening here with this equal sign. Secondly, we can assign one structure to another. Thirdly, we can pass a structure to a function as a parameter. All those three things have been proved by that very simple output that we just had a moment ago. That's pretty much it. I told you it was pretty straightforward using structures with functions. There's a little bit more to it, which you'll find out when we get to the pointers chapter, but for now, that's all there is to it.